students, we are solving the IB Math AHL past paper questions, and currently we are solving the IB Math AHL May 2022 paper 2 time zone 1 past paper. Today we will be solving the question number 10 of this paper. You will be getting the links to all the previously solved questions of this paper and of the other papers in form of playlists in my channel as online math tutoring classes. So without any further delay, let us start answering question number 10. The maximum mark is 20. It says consider the function f of x equal to square root of x square minus 1, where x belongs to the set of real numbers which lie between 1 and 2. That means x is greater than or equal to 1 but is less than or equal to 2. Now, contains several subparts. I have brought in the first two subparts, and the subpart A says sketch the curve y equals f of x, clearly indicating the coordinates of the endpoints. It contains just 2 marks. It is a paper 2 question, so we may use the calculators to find the shape of the graph. Okay, the expression for the f of x is square root of x square minus 1. So let us go to the graph, and this is square root of x square minus 1. Okay, and enter. But you're seeing the graph, the total graph, but over here they are saying the x values lie between 1 and 2. We go back to this graph and we go to menu and Windows Zoom, Windows Settings. From here we can take it is between 1 and 2. So I can take uh, it as 1 and this as 2. Okay. And now you see you are having this type of a curve. Let me change the y values as well. So again, going to the Windows settings, and let me take this as -1 to say maybe 3. Better. Okay. And these are the endpoints actually. So we can find the y values of the endpoints. F of 1 when x equal to 1, what is f of 1 equal to? It is 1 square minus 1, that is 1 minus 1, square root of 1 minus 1, or square root of 0, which is equal to 0. Okay. And what is f of 2? It is equal to square root of 2 square minus 1. That is 2 square is 4, 4 minus 1 is 3, square root of 3. Okay. So we are having the endpoints as, the coordinates of the endpoints as 1 comma 0 and 2 comma square root of 3. Square root of 3 is 1.7 something, and it is a paper 2 question, so you may find the value of the square root of 3 as well, okay, if you are not sure. And now we have to sketch the graph. The graph is of this shape. We are seeing it is a continuous graph. It is rising and it is concave down. Now this is very important. You can connect 2 points. You have 2 points. You can connect them using a straight line. You can connect them using a curve which is concave up. or you can connect them using a curve which is concave down. So the concavity is very important when you have to sketch the graph, because the graph, you are getting the shape of the graph from the calculator. You will be just copying, but you have to copy the shape exactly. So therefore, you are getting the two endpoints and you are seeing it is continuously rising, and there is no discontinuity in between, there is no asymptote in between. So that is fine. But what is the concavity? It is concave down. See, it is concave down. Okay. So let me just draw the, okay, let me take this. And okay. So this is the y-axis and this is the x-axis. This is the 0, 1, maybe this is 2. Okay. And the point is 1 comma 0. So this is one of the points. And the other one is, okay, let me take this as 1 and this as 2. Okay. So the other point is 2 comma square root of 3, which is 1.7 something. So take it up maybe. Okay. And we have to connect it like this. Sorry. We have to connect it like, okay. It is concave down. And this is 1 comma 0. You may write it again. This is 1 comma 0 and this one is 2 comma square root of 3. Okay. So we, because these are -1 and -2, you may write these. It's up to you. And this is the graph of f of x is equal to square root of x squared minus 1, where x is between, you have to write this as well because this is not the complete graph. It is the graph of the portion where x values lie between 1 and 2, both included. 1 and 2 are included. Okay. So this was the answer for the part A. Coming to the part B. Now this part B contains two further subparts, I and II. The I says show that the inverse function of f is given by f inverse of x equal to square root of x square plus 1. Okay, fine. So in place of f of x, let me write y. So y equal to square root of x square minus 1, and then what do? We just write x in place of y and y in place of x. So this is x equal to y square minus 1. And now we have to make y the subject. So we will be squaring both the sides and we will be getting x square equal to y square minus 1 or y square equal to x square plus 1. Now we have to get the expression for y and not y squared. How to get that? We will be taking the square root of both the sides. So this is y equal to, now when we take the square root, we get the positive square root and another is the negative square root. But which one should we be taking? Now, for the inverse function, because for the original function f of x, we are seeing the domain is between 1 and 2 and the range is between 0 and root 3. So, since the range of the original function is from 0 to root 3, therefore the domain of the inverse function should be equal to 0 to root 3. That means all positive numbers. Therefore, we will be taking the positive square root. Okay? So, this is x square plus 1. Let us write the reason, because the range y is between 1 and 2. Okay. The domain is between 1 and 2 for the original function. So the range is between 1 and 2 for the inverse function, and the domain of the inverse function is between 0 and root 3. Okay. So since y is between 1 and 2, all are, first of all, I said between 0 to root 3. The 0 to root 3 is the domain of the inverse function, but now we are dealing with a range. The y values will be between 1 and 2. So all are positive numbers, therefore we will be taking the positive square root. Okay. So this is the expression. So therefore, f inverse, now let us write the f inverse of x in place of y. So f inverse of x is equal to square root of x square plus 1. Okay. And now we come to the I part. State the domain and range of f inverse. We know the domain and range of the original function, so we may write the domain and range of the inverse function. In fact, we have already written the range of the inverse function. Let us write them again. So domain is x is between 0 and root 3, and range is f inverse of x is between 1 and 2. Okay. So this was the answer for this part I. And this is the domain, and this is the range. Okay. The curve y equals f of x is rotated 2 pi about the y-axis to form a solid of revolution that is used to model a water container. Okay. Subpart C, it has two further subparts, I and II. I says show that the volume V meter cube or the container of water in the container when it is filled to a height of h meters is given by V equal to pi times 1/3 h cube plus h. Okay. Now, how are we having the water container? Let me draw a rough sketch. This is 1, this is 2, this is -1, this is -2. This one is, of course, x, this is y, and this is 1, this is 2. We had the shape of f of x, which is square root of x squared minus 1, where x values lie between 1 and 2. 1 and 2 are included. So we had this type of a curve, and this point was 2 comma root 3. So the highest value of y is root 3. Okay, and the lowest, the bottommost value is 0. Fine, and this has to get rotated about the y-axis. So we will be having another one of this shape. So this will be the water container. This will be the water container. And now they are saying, show that the volume V meter cube of water in the container, when it is filled to a height of h meters, maybe let me take h as over here. Okay. This is h. Y value is equal to h over here. Is given by V equal to pi times 1/3 h cube plus h. And now what is the formula for the volume of the solid generated? You will be getting it in your formula booklet. I am just writing it. So this will be pi e to b x square dy. Okay. Now we have to get the expression for x square from this function expression. So in place of f of x, let me write y. Y is equal to square root of x square minus 1. And we have to get x square, rather we have to make x square the subject. So we are squaring both the sides to get y square equal to x square minus 1, or x square is equal to y square plus 1. Okay. So we will be substituting y square plus 1 in place of x square. And what about these values? What is the value of a? What is the value of b? The lowest, the bottommost value of y is of course 0. And the topmost value is root 3, but over here we will not be taking the topmost value because the water has been filled up to the height of h meters. So in this case, the b value will be equal to h and the a value will be equal to 0. Okay, so we come to this place. V is equal to pi 0 to h, and in place of x square we will be writing y square plus 1 dy. So this is after completing the integration, we get pi and y cube over 3 plus y and 0 and h. So this is pi h cube over 3 plus h minus 0 cube over 3 minus 0. Therefore, v is equal to pi 1/3 h cube plus h. Okay. shown. And now this was CI. I'm not sure whether I have written it somewhere, but I am writing it again. Okay, so this was CI, and now we come to the II part. It is saying, hence, determine the maximum volume of the container. What was the maximum height of the container? Y was equal to root 3. So we will be substituting root 3 in place of h. That is what we have to do to get the maximum value. Okay. So since the maximum y value is root 3, therefore V max is equal to pi and 1/3 times root 3 whole to the power of 3 plus root 3, and root 3 to the power of 3 is 3 root 3. So this is pi 1/3 times 3 root 3 plus root 3. Root 3 plus root 3 is 2 root 3. So this is 2 root 3 pi meter cube. This is the exact value. Or else we may give this value in decimal form. So it is 2 times root 3 times pi. It is 10.8828. So up to 3 significant figures, it will be 10.9. 10.9 meter cube up to 3 significant figures. Okay. T equal to 0, the container is empty. Water is then added to the container at a constant rate of 0.4 meter cube per second. And the question for the subpart D is, find the time it takes to fill the container to its maximum volume. What was the maximum volume? It was V max was equal to 2 root 3 pi. Okay. And what is this part? 2 root 3 pi meter cube. Unit is meter cube. And this is 0.4 meter cube per second. Meter cube is just referring to the volume, and per second, second is time. So it is the changing of the volume of the water in the container every second. The volume is getting increased. So it is the change of volume with respect to time. Therefore, it is dV dt. Okay. So dV dt equal to 0.4 meter cube per second. Okay. Now we need to find the time it takes to fill the container. dV is what? dV is the change in the volume. Change in what two volumes? The change in the initial volume and change in the the volume at the initial stage when t equal to 0 and the volume at the final stage when t equal to something. So dv is equal to v final minus v initial. Okay? And what is v final? It is 2 root 3 pi. And v initial, the container is empty at the initial stage when t equal to 0. So this is equal to 0. So dv equal to 2 root 3 pi. Okay. Therefore, we can write dt as dv over 0.4, and this is 2 root 3 pi over 0.4. dt is the total time taken. The initial time is t equal to 0, and what is the final time? You just subtract those two and you get dt. So this should be equal to, we will be using the calculator. Okay. Let me once more write the same thing. 2 times root 3 times pi over 0.4. Okay. 0.4. 27.2 seconds up to 3 significant figures. Okay. Equal to 27.2 seconds up to 3 significant figures. Okay. So therefore, time taken because the initial time is 0, therefore dt will be, the time taken is 27.2 minus 0, which is 27.2. So 27.2 seconds up to 3 significant figures. Okay. If you are still confused, let me write this also as dt equal to t final minus t initial, and this one dt we have found, calculated this to be equal to 27 minus 2, is 27.2 rather, equal to t final minus t initial is 0, t equal to 0 initial time. So t final is equal to 27.2, that is the time taken to fill the water container completely. Okay. The part E. Find the rate of change of the height of the water when the container is filled up to half of its maximum volume. The maximum volume was found to be equal to 2 root 3 pi. So half of it will be half of 2 root 3 pi, which will be equal to root 3 pi. So half of P max is equal to root 3 pi. And when the rate of change of Right. So we are required to find dHdt. Okay. So we are having this expression containing connecting the V with the H. So this is V equal to pi 1/3 H cube plus H. Okay. So if we differentiate this expression with respect to t, what do we get? On differentiating, this is maybe 1. With respect to t, we have dv dt equal to pi 1/3 times 3h square times dh dt plus dh dt. Okay. So, and dv dt we have found that to be equal to 0.4. Rather, we did not find it, it was given. So, we can write therefore 0.4 is equal to pi, and these two will be getting cancelled, and we will be having h squared plus 1 dh dt. And we need to find this dh dt. For that, we require the value of h. Okay. So, how to get the value of h? They have said the volume will be root 3 pi, which is half the maximum volume. So, we will be finding the h value from this expression. Okay. Let us find the h value from that part. The v is equal to root 3 pi, and this is equal to pi 1/3 h cube plus h. And we can cancel these two. And so we can, let us just multiply the entire equation by 3. I just want to get rid of this. So I am having 3 root 3 is equal to h cube plus 3h. Okay. Or h cube plus 3h minus 3 root 3 equal to 0. Now this, this is a cubic equation. Okay. And it is a paper 2 question, so we may use the calculator. Find menu, algebra, polynomial tools. The degree is 3. Real roots. Okay. E1, E3 x cube. In place of x, we are having h, doesn't matter. It is 1h cube. So this is 1. Then it is x square. We don't have any h square, so this is 0. And then coefficient of h is 3. And finally, the constant term, it is minus 3 root 3. It it is. Okay. Minus 3 root 3. Okay. Fine. It is giving the h value as 1.181826. Okay. It is giving only a single value. If you are confused that how can you have a single value for a cubic equation, let us move on to the graph and you will be knowing the reason. Okay. So let us go to the graph. And it is x cube x cube plus 3x plus 3x, or let me 3 times x, that will be better, minus 3 root 3 minus 3 root 3. Okay. See, you are having only a single 0. And if we just try to find the 0, what is the 0? 1.18183, that is the same thing that we were getting. 1.1818 in place of 26, they have given 3. Okay. So the h value is 1.18 up to 3 significant figures. Or since this is not the final answer, let me take 1.1818. So this is giving the h value as 1.181826. Okay. Now we will be substituting this h value in this equation. Okay. So dh dt is equal to 0.4 over pi times 1.181826 square plus 1. Okay. So now let us find this value. 0.4 over pi times 1.181826 square plus 1. And then we move up and okay, it is 0.053 up to 3 significant figures. Okay, 0.0, sorry, up to 3 significant figures, we have to take up to 1. 0.0531. This is equal to 0.0531 up to 3 significant figures. 0.0531. Okay. And this was the question. Find the rate of change of height. So I have to give the unit as well. Rate of change of height is 0.0531 meter per second up to three significant figures. Okay. So this is the answer for the subpart E. And this completes the answering of the question number 10 fully. And thank you for staying with me till the end. I am Nilanjana Sanyan. I'm an online IB Math A, SL, and HL level tutor. I tutor students from both within India and outside India in one on one and in small group online tutoring basis. Okay. So currently I am solving the past papers of IB Math A, HL, and I am uploading them in my YouTube channels. So in case you are liking my explanations, please to give this video a like and please to share this video with your friends so that even they may get benefited by watching this video. And please do not forget to subscribe to my YouTube channel. It will be motivating me to make more math videos for you. And we meet again very soon. In case you have any question, you please feel free to write to me in the comment section. I'll be trying my level best to answer your questions. Okay. And we meet again very soon in our next session where we'll be solving question number 11 of the same paper. So till then, bye.